So that when you take a look at, when you take, oh, I'm going the wrong way here. When you take a look at comparing a Zigbee, a Bluetooth, and ANT, if let's say you're only sending a message once per second or once every 2 seconds, you can see the difference in the battery life that you get from these various protocols. Now, of course, all these different, I'm going all over the place here. All these different protocols have different uses, again, depending on the data rates that you want to be transferring at and the range that you want to be delivering that over. So the ANT protocol was really designed to be in that lower quadrant here for very low data rates, long battery life over short distances. So it operates, ANT operates in the 2.4 gigahertz range. It was designed to be working between battery-powered devices like our foot sensors and the watches, but indeed a lot of other devices that I'll be showing you down the road as well. It was formally born in 2004, but it came out of some of the original work that we did with our first product with Nike in the year 2000. So this was our first product, again, a battery-powered foot sensor device talking to a sport watch. But over the years, many companies have picked up on this because they also had the need to be transferring low amounts of data to battery-powered devices, and so an ANT Plus Alliance was created to permit the exchange of information between these battery-powered devices. And you can now see a large family of companies that are now using this. And the advantage with that, of course, is that if you're a part of the ANT Plus Alliance, then these devices can all talk to each other. So that really permits the interoperability of these devices and the exchange of information between them. Now this shows a sporting application, but you can see here that a large number of devices from a bike and from various sensors on the body are all talking to, let's say, a watch or a bike, a computer, and then uploading to a PC from that. And ANT Plus is really taken off. For example, in the Tour de France this year, 9 out of the 10 top finishers were using ANT-powered devices for that. So although this is showing the sports side of things, as soon as you have a standard that has some adoption to it, you can then get a lot of companies coming in and taking part, and this could well be something that the medical side of things could go for as well. So already there are a number of devices, showing that a large number of medical devices that are being developed that work on the ANT protocol, including those created by Dynastream, like heart rate sensors, activity monitors, and so on. The work that we're doing now at the university is involving smart prosthetics, and in here we are going to ultimately enable people with spinal cord injuries to be able to walk again. And to be able to do that, we're putting accelerometers and rate gyros to act as a feedback to activate the various muscle groups in the leg to be able to enable people to walk again. So that as you're going through the walk cycle, the accelerometers and rate gyros will then give you some idea as to the stages of the gait that you're currently in, and then with that you can activate the various muscle groups to be able to get the walking to work in a natural fashion. So when you're going to select a wireless scheme, there are really a large number of things to consider, and I've gone over some of them, and here's just a more detailed list of some of the things that you have to be able to consider for that. And what, for any particular application, what are the driving factors. For us, it was very definitely the power consumption side of things. We need to have very long battery life. For medical applications, when you're going to, for example, embed that beneath the skin, there are other things to consider as well. In one of the earlier presentations, we saw a little bit about some of the different frequency bands that could be considered for this. We heard about the low 402 to 405 megahertz one, which is a band for implanted medical devices. The more common Bluetooth, Zigbee, and ANT is in the 2.4 gigahertz range. Various network topologies can be considered, again, for depending on the applications that are required for that. So what's the future work for this? Well, of course, with RF, the cost continues to fall, the power requirements are dropping, more and more people are getting on board. But I think the biggest thing is what a standard is going to be adopted for this. Bluetooth, very popular with computers, cell phones, and so on, but very, very power hungry. We've shown in the sports side of things that ANT is making big inroads for that. Are there other standards to follow for the medical, which may incorporate, a lightweight version of a Bluetooth or some aspects of ANT? I don't know those answers yet. And as has been previously mentioned, the energy scavenging or self-powering device kind of thing is certainly a very interesting way for these small devices as well. Thank you.